This is Honors Geometry, Lesson 2.1, Inductive Reasoning. First thing we're going to do is take a look at this sequence. It says, what is the next figure in the pattern? So to me, it looks like that blue is swinging around counterclockwise. So from here to here to here. So I think the next figure is going to be letter C. Next section, we're going to look at number sequences. It says, describe the pattern in the numbers, then write the next number in the pattern. So the first one, we're going from 1 to 4 to 9 to 13. So it appears we're adding 4 each time. So it looks like the next number would be 17. 3, 12, 48, 192. It looks like we're multiplying the previous number by 4. So I'm going to take 192 and multiply that by 4. So it looks like the next number in the sequence would be 768. And the last one, 10, 5, 2.5, 1.25. It looks like we're cutting it in half or multiplying by 1/2. So I'm going to take that 1.25 and I'm going to divide it by 2. So the next number in the sequence would be 0.625. A conjecture is an unproven statement that is based on observation, and that's what we've been doing. We're just making observation. We're not proving anything. And what we're using is inductive reasoning to find the pattern. All right, we're going to try another one. It says if you have 3 non-collinear points, there's 3 ways to connect them. If you have 4 non-collinear points, there's 6 ways. So I'm going from 3 to 6 to 10 to 15. So we could easily sketch 7 non-collinear points and connect them. 1, 2, 3, 4, 5, 6, 7. But an easier way might be to just look at the number sequence going on. So I'm going from 3 to 6 to 10 to 15. So it looks like I add 3, add 4, add 5. So I'll probably be adding 6. So I'm going with the fact that if I had 7 non-collinear points, there were going to be 21 different ways to connect them. To show a conjecture is true, you must show that it is true for all cases. To show that a conjecture is false, you simply find a counterexample, and then a counterexample is a specific case for which that conjecture is false. So if you can come up with one example where that statement is false, that's your counterexample. Number 14, it says if the product of two numbers is positive, so we're multiplying 2 numbers and our answer is going to be positive, then it's saying those 2 numbers must be positive. So if you can come up with an example where your answer in a multiplication problem is positive, but your numbers are not positive, that's our counterexample. So how about we try -3 times -4, and we get positive 12. So that would be our counterexample, that if you multiply 2 negative numbers, you still get a positive answer. It says the product of quantity a plus b squared is equal to a squared plus b squared. Okay, so they're saying, hey, you can distribute that squared. Let's see if it's right. So I'm going to try 3 and 4 again. 3 plus 4, quantity squared, that'd be 7 squared or 49. And what if I square the 3 and then square the 4? So I'll get 9 plus 16. That will give me an answer of 25. And you can see it's not the same thing. So that would be my counterexample, 3 and 4. Next section, it says, write a function rule relating x to y. You may see what's going on in this sequence of numbers, but now we got to put it into a function. So it looks like on the first one, it looks like we're going down by 4 every time. And I want to put that into y equals mx plus b format. So I'm going to say in order to get y, I'm taking my x and subtracting 4 every time. The next one, you might say, hey, my answers are going up by 2 every time, but we've got to write that as a function. So really it looks like what we're doing is we're taking our x and doubling it or multiplying by 2. So we're going to say y equals 2x is the answer I'm looking for. If you struggle with how to do that, you can always go back to algebra. You can calculate the slope, which is y minus y. Any 2 points, I'm going to choose 4 minus 2 over x minus x. So I get 2 over 1. So my slope, or my m, is 2, and that's what we just had. And then remember, to get the b, you put into y equals mx plus b. You choose a point. I'm just going to choose 1, 2. So in place of y, I'm putting 2. We said our slope was 2. And the x is 1, and I'm trying to figure out what my b is. So I get 2 equals 2 plus b. Subtract 2 from each side. It looks like my b is 0. And so that's why we don't have anything here. So if you can't just recognize the pattern going on, go ahead and just use your algebra and come up with your y equals mx plus b. All right, last one, another set of number sequences. This one, it looks like they're taking, think of that as 2 over 1. They're taking the numerator and making it the denominator, and then they're increasing it by 1 to get the numerator. So we're going to take this 5, that's going to be our new denominator, and then we're going to increase it by 1. So we're going to say the next number is 6 over 5. Number 24, we're going from 1, 8, 27, 64, 125. I recognize those as cubes. So it looks like we have 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed. So we want to go 6 cubed, or 6 to the third power. So I'm going to punch that in my calculator. 6 to the third power is 216. And the last one, we're going from 0.45 to 0.7 to 0.95. So it looks like we're adding 0.25 every time. So I'm just going to go ahead and take the 1.2 and add 0.25, and the next number in our sequence is 1.45. Please try the problems on Schoology. Let me know if you have any questions. Thank you.